This is the continuation of the first lecture. Let us say this is lecture 1.2, and we have studied the operational amplifier, ideal op-amp characteristics, and the inverting amplifier till now. Let us look at another configuration, and that is known as the non-inverting amplifier. Amplifier is something that amplifies. An amplifier has a symbol of a triangle. That is why we use Opamp symbol as a triangle. If we have such a configuration that instead of connecting the input to the non-inverting pin through a resistor, let us connect the input Vi directly to the non-inverting pin, and at the inverting side we have the resistor. It is now directly shorted, so this is Ri. We have the feedback resistor, and you can see that the feedback resistor is still between the output and the inverting input, and we know that RL is not going to play any role in here. I have eliminated that for now. This is the output. So let us try to find this VO in terms of Vi. Again, what we know for sure, we know this is at 0 volts, this is at 0 volts. We don't actually need to write this. I'm just writing this for your reference. So we have 0 volts here. This voltage source of Vi volts, Vi basically says that the voltage here would be Vi. And the ideal op-amp characteristics say this must also be Vi. Why? Because these two must be equal. So we have Vi here. Can we now write the NVA equation for Vi? And we know there is no current flowing into here in here. So we are going to have Vi minus 0 over Ri, the outward current through Ri, plus Vi minus Vo over Rf equal to 0. So we can see that we can now solve this as Vi 1 over Ri plus 1 over Rf is equal to Vo over Rf. So what do we get? Vo is equal to, this Rf will go here. We are going to get Vi into Rf over Ri plus Rf over Rf. What do we get? Vo is equal to 1 plus Rf over Ri into Vi. So we still have Vo is K times Vi, but here K is positive. So you see 1 is a positive number, Rf is a resistor which is a positive, Ri is positive, positive or positive is a positive added to a positive value is a positive value. So this factor is positive now. That is why it is a non-inverting amplifier. So if we have Vi equal to 5 cos t as in the previous example, and say Rf is the same 2 kilo ohm resistor and Ri is the same 1 kilo ohm resistor, then in this configuration Vo would be equal to 2 over 1 is 3 times 5 cos of t, which is 15 cos of t volts. However, it's very important that plus minus VCC, the two voltage sources that power on the amplifier, must also be larger than this 15 volts, because the output voltage of an operational amplifier can only be as large as plus minus VCC. So if the input varies from between 5 and minus 5, the output would vary between 15 and minus 15. And obviously the zero crossings would be at the same time instance. And similarly, for a DC case, in this course LCA, we are only considering DC voltage sources. So we will not really be drawing these cosine and sine. We will not be using these in the exam. It's just for your guidance, and we will never use them again. In a inverting configuration, so if Vi is equal to say 5 volts, Vo in this case would have been 15 volts because of the same reason. And it is very simple to solve this.